This is a spring coupling. Its primary benefit is to absorb peak load impact energy instead of transmitting it directly into the system. These types of couplings can also handle some degree of misalignment as well. This particular design uses 4 small coil springs and 3D printed materials. Here is the final product. Everything is 3D printed with the exception of the springs and the hot glue used to hold the shafts in place. Giving it the flywheel test, you can see it spins smoothly enough. There's a large contact area between all the surfaces with the shafts and the frame, and that's what's causing some additional friction here. I made them larger so that we had more precision. Using the drill, we can see that things are moving all right. You'll notice that there's some oscillations of one of these shafts, and it's just a poor installation on my part. Poor design and poor installation. Here's a high-speed film testing out the shock absorbing capability of the springs. You can see that the drill comes to a complete stop and the flywheel then also stops, and that energy is absorbed directly into the spring system. Here's a close-up view, and you can see the compression of the spring. So overall, is this a practical print? Is this something you can do with 3D printing? I think that the answer is yeah, you can totally do this with 3D printing. Just keep in mind the criteria you need to design for, and it should work out okay. I've been inspired to learn more about mechanical design by retired mechanical engineer and YouTuber Thang010146. His YouTube channel has over 3,000 mechanical animations that he created himself, and he's constantly creating new ones almost daily. I've been a fan for a while now, and I would like to challenge myself to recreate some of his designs and 3D print them to see how well they function out of a printer. He's a genius. You gotta check him out if you're